All right, page 3. We have our frog in the rainforest, and all I really care about is that equation where x is the horizontal distance in feet. X is the horizontal distance in feet, and y is going to be my vertical distance of feet. Remember, f of x is the same as y. Here's our vertical distance in feet. I look at my parabola and I know it's negative, so it's going to go down like a frown. I'm going to care about the vertex. I'm going to care about where the frog lands at 0. All right, sketch your graph, label each vertex. You label each axis, the vertex, and 0. Okay, going to go to my graphing calculator, and what is the maximum height of the frog? So we're going to go into y is equal to, and we're going to enter that equation in. So we have negative 2 divided by 27x squared plus 4 divided by 3x. All right, so when it's time to see a picture of my graph, if I do zoom 6, I can get an idea of where my graph is, and then I can go change my windows. I'm going to go here to Windows, and I don't need anything beyond -1. I like -1 because I get to see my axes, but I don't need to go into quadrants 2, 3, or 4. My graph looked like it kept going, so I think the frog needs more time, and my y maximum looked okay. So let's take a look at where the frog is going. All right, it says, what is the maximum height of the frog? That's going to be up here. So I'm going to go ahead and use second calc. I'm going to find the maximum, put my cursor to the left, my cursor to the right, and my maximum height of my frog happens up here at the vertex, where my x value of 9 gives me an output of 6. So I know that, here's my distance, and here's my height. So I know the maximum height of the frog is going to be 6 feet. When the frog lands on the second rock, how far away is it from where it started? This question's asking me to find this distance here. How far away is it from where it started? So I'm going to go back to my calculator. I'm going to go to second and calc, and I'm going to ask for my 0. I'm going to put, and I want my positive 0. There's 2 zeros, one negative, one positive. The -1 is an extraneous solution. So this one tells me at a distance of 18 feet, the frog landed. So this distance here represented 18 feet over where the frog landed. How far away is it from where it started? 18 feet. Okay, next up. That expression describes the profit of a company that customizes bulldozers when it customizes X bulldozers in a month. Okay, so my X represents my number of bulldozers. And this here represents my profit. So my profit is going to go on my y-axis. This graph has a negative A value. So the profit of the company, I make a certain amount of money, and then I cap out, and then I stop making money if I make too many bulldozers. Okay, so I go to my graphing calculator, and I'm going to enter my new equation. That's a lot of bulldozers. 2,500x minus 2x squared. So without changing my window, I'm going to go ahead and look at my graph and see what I see, which is nothing, which means that this graph exists much higher. So I'm going to go to my window, and I'm going to give myself a pretty high maximum to see what I can see with this graph. So we'll go ahead and graph. Still no bulldozers. Now I'm going to go to the table of values, and oh my goodness, look at how many bulldozers I need to find to even see my graph. So we're going to go back to my window and recognize that my maximum needs to be 1,000. Did I say 1,000? Should have been 10,000. Add another 0. There's my bulldozers. And I'm still not even close. So, wow, I make a lot of bulldozers. Let's go to Y and see what happens if I make 100 bulldozers. Again, not even close. So let's make 20,000 bulldozers, for $20,000, and let's make 200 bulldozers. Still striking out. Getting pretty sick of bulldozers. Million bulldozers. This is ridiculous. Let's try zooming out. Finally, my goodness. Let's see what we have after we zoomed out. How many bulldozers per month must the company customize to make the maximum profit? I still can't even begin to see, so I'm going to zoom out again. All I need to see is the top there, finally, is the top of my vertex. So we'll go ahead and we'll do second calc, and I want to find that maximum. How many bulldozers do I need to make? Put Mr. Blinky to the left. Put him to the right. Okay, I need to make 625 bulldozers. So your maximum value here is going to be 625 bulldozers. And check it out. $781,250 is my maximum profit. Okay, how many bulldozers per month must be customized to make the maximum profit? 625 bulldozers. What is the maximum profit? 781,250. I'm going to go back to my window and see, because I had us kind of checking that out. Oh, look, it made my own window for me, where it went to $850,000. Okay. That's a lot of bulldozers. All right, ready for Marie throwing her softball in the air? The ball leaves her hand when it is exactly 5 feet from the ground. Hey, that's our y-intercept. We don't talk about that a lot. The height of the ball is a function of time. So I know that my height is my y-axis, and it said it's a function of time. And again, my graph is negative. So here's my 5 feet from the ground, and here's the ball, and this is where it lands. This is its maximum height. Okay, sketch your graph, label each axis. Here's your vertex, and then the 0. How long is the ball in the air? I'm asking you to calculate this time here. How long is it in the air from the time it leaves her hand to the time it lands? So we'll go ahead and remove the bulldozers. Okay, negative 16x squared plus 40x plus 5. And let's just zoom 6, give us a standard window. And we can see all the action happens real fast, only in 1, 2, 3 seconds. So when we go to our window, our x minimum will be 0 or negative 1. Everything happens in less than 5 seconds. Y minimum is negative 1. And she's throwing the ball up. I don't know, let's give us a height of 50 and see how that works. Okay, that's pretty good. So how long is the ball in the air means I'm finding the zeros. When I go to find the zeros, I'm pressing second calc. 0. Move Mr. Blinky to the left. As soon as these y values go negative, I know I've crossed the axis. And this tells me that at 2.62 seconds, the ball hits the ground. So how long is the ball in the air? 2.62 seconds. What is the maximum height the ball reaches? Which means I'm solving for my maximum height. That's going to be my vertex. So I'll go ahead back to my graph, and I'll go to second calc, and I want to go to my maximum, and I go to my left, I want to go to my right, and at 1.25, we'll go ahead, seconds, the ball hits 30 feet in the air. So what is the maximum height the ball reaches? That's going to be 30 feet in the air. All right, on to page 4.